matrix A,
Mm-hmm.
matrix A, which like 2, 3, 4, 5. I gave you a matrix B,
Yep.
let's say of a 3 cross 3 matrix, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, what usually we do with the help of variables? You're able to see my screen, right?
Yes, yes, I can.
Okay, okay. So basically, int A is equals to 5 if I do. What I do, int B is equals to 6, okay? And now I can easily
Yep.
assign the variables, like A is equals to B, right? Now A have the value 6. Similarly, what I want to do here is, I want to assign matrix A equals to like a B. Now I want to write a function overloading a function here so that like sorry, not function, operator overloading. I have to overload this operator so that if I write, because inbuilt it's not there, right? I can't assign a
Yep.
matrix to another matrix, so I have to write this function to get A equals to B, right? So but you have to careful about two things here. Firstly, you have to, obviously you can't just copy, you have to allocate the,
Yes.
change the resize also, right? You have to resize as well,
Yeah.
resize as well. And the second thing is copy. Just second thing is copy the elements. So if I just show you the code part, go to the code part. So what we have done is, like where it was, copy, resize. Okay, this is fine. See, yeah, I think below. Yeah, I think above only, right? This was, I think, previously only done, but okay, like, it's fine. Minus equal to, like we have done this previous, I think the previous only. Yeah, yeah. Let me just copy this. So, okay. Mhm. So, so what? Oh, just a second.
Mm-hmm.
Wait. Hmm. Basically, what we have done is like we have overloaded the operator equals to. So basically,
Yep.
it is a return type. Like we are returning an object only, right? That's why we are returning this name of the matrix, and this is the matrix which we want to do. Like this is like input is, we already discussed how operator overriding works, right? Like this A we
Yes.
have to assign, this is our in what you could say, argument argument parameter. So yeah, this is how it works. So we have right equal to, and that's whatever you want to give. Now first of all, we checked if this they are already same, while you want to allocate any different memory, right? So we checked this
Yeah.
we I already discussed with you. This means the this object of our class, object of our class, currently, like currently whatever you can say is represented by this. Basically it is a pointer. So basically they are saying like whatever you have said m, or I have said this, are they both same? They already same, just return our same only, right? No need to
Yep.
allocate or deallocate the memory. Now now suppose
Mm.
they're not same. So basically first of all we deallocate the memory of the matrix, whatever we have, right? Of our
Yeah.
class matrix. We relocate the memory, and then what we do, we assign the new size to it, like whatever m, I am assuming m to be m and all to be n cross n matrix, okay? N con n matrix,
Yes.
only one assignment I'm saying. So I am changing my size to whatever m size have. So m dot n equals to n, okay? So this is our original, like class matrix. I clearly specify class matrix size. Okay, this is our class matrix size, and we are assigning with the input size. This is the input
Yep.
size, and just we just assign the size, and then we allocate the memory. We allocate the memory
Okay.
for n. and then we just call the copy matrix. Copy matrix we already defined. Like it's not like we have defined it. It's not an inbuilt function. So we have defined the copy matrix. That it is the same. Nothing because we already made the size same. It's just copying the
Mm-hmm.
element same. So yeah, it's very simple. And we
Okay.
just return our this class objects. That is fine, I guess. Yes.
Okay. Okay.
So this is fine. So yeah, this is like how we do the equality operator. Now let's do the next part. So basically now at the this we have done. So we have to cascading, assigning a bigger matrix or like whatever, like what you want to do. Okay. Now
Yeah.
whatever on the left side will be transferred, like whatever help in case of integers, right? Same way. So now the second question they are saying plus equals to. Now see, they have two versions. What it means, let me just explain you. See, uh, plus equals to means like suppose I give you a matrix. Now they are saying I will do two things. I can do this also, right? Plus equals to b, or I can do this also. Plus equals to 3. Let's say what both of this means. Like operator is plus equals to only. Now in first case, I just need to add two matrices. That's all. In the A itself. So that let's say 4, 5, 6, 7, 8, 9 is there, and we have plus one 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 zero 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 zero. Okay, something I'm just gave you an example. Suppose you write this code, like how you write a plus equals to b in case of integers, right? Same. They want to achieve the same things in case of matrices also. We are defining the algebra of the matrices as well.
Yep.
So, so what we have to do? We have just to like whatever we have to write, uh, like a plus b. If I write, we have already done this part. But what we have done, this we return in another matrix only. But now what we are doing is we are changing our a only, a itself. So basically, it's like a equals to a plus b. We are defining
Mm,
this. So basically, yeah, this is just adding the matrices. So let's say like 2, 2, 3, 4, 6, 6, and 7, 8, 10. This is how we added the matrix. Now, other part was this. Like now two version they are saying this is the second version. This is the first version and this is the second version. Because basically we can add our integer also, right? What it means add 3 to every element. So what will do? We'll just suppose we got a plus equals to 3, so we will add each element a 3. So let's say what will happen, 4 5 6 like 7 8 9 and 10 11. So basically every element is added by 3 plus 3. So
okay.
basically now you tell me, like I will ask you one question, like what if I talk about this, like plus equals to is obviously operator overloading. This is operator
Yes.
overloading. That is fine. But what is this? Like I want two versions. Like what is this called? We have discussed it.
If I want to do what, sorry?
See, we have two versions of same thing, right? We have
Oh, like what is
overloaded it.
plus minus called?
We have in one case we are giving another object only, and in one case we are given an integer. And we want to perform differently. Suppose I gave this argument, I gave a matrix as an input. I should do this thing, whatever given, add two matrices. But suppose I gave an integer as a plus equals to, then I should do add 3 to each element of the matrix. So
Yeah.
in both the versions, like what is this called? Like we have discussed this something, like giving different
Mm,
arguments and all, if you able to recall, like in something overloading only, but which type?
uh,
Like what, which type of overloading we have discussed? Like what are the overloading we have discussed?
it'd basically just be. Give me 1 minute. Let me
Yeah, yeah,
remember.
sure. Try to think. So basically, like there were, we have like same
Would it be
parameters.
referred to like just? It would just be the operator overloading, right? Like
Operator is fine.
arithmetic,
Operator is we're doing. Like before operator, what we have discussed. Try to recall.
arithmetic operator overloading.
Nee, operator is fine. apart from operator overloading,
Oh,
like
okay, okay.
same name, different parameters, if you're able to recall something. Like I
Plus,
gave you this example, right? Fun A we call with an integer, and fun A B we call an integer. What is this called? Like same name, different parameters. Ship example I gave you, like weight,
mm,
different weights, and if we have additional information, the cost will be calculated differently. So which type of
mm,
overloading it was? Like there were only two types of overloading, right? One is operator overloading, another one is
function?
yes.
Mm,
Yeah, yeah, exactly. Function overload.
mm,
That's all,
okay.
right? So basically,
Yep.
here we what we are doing, the operator, everything is same. Just we are giving different parameters. In one case, we are giving a matrix, and one case we are given an integer. So yeah, that's how we implemented it. Let me just show you. See, this is copy operator equal to yeah, this one, right? Let me just this for you. See, what we have done is like there are two methods, but there are two versions of
Yep.
the same thing. See, the same name, same thing, right? Now what we have done here, we are pass an argument as value, and here we pass another matrix. So that was the difference. So basically, this both individually, they can ask this. Like you have to differentiate and you have to understand every concept very importantly. Like individually, it is operator overloading.
Yep.
We are using the concept of that. But if you talk about the compare A and B, the first version and second version, two versions are like that is function overloading. Function overloading. So yeah, that is try to think these things. You will recall, okay, yeah, this was function overloading. Okay, yeah. So you will get it more. Okay. Yeah. So let's try to understand this thing. So basically, like this was now obviously I need to check the argument should be same or not, right? Like both have same sizes. Then only I can add A to B, right? And this was just same
Yep.
thing. We are just adding two matrices. Just the difference was we are not allocating a different matrix. Like we are not in the first part what we have done. Like we have operator overloaded this one, right? Operator plus. So what we have done was we have resultant C matrix, we have stored the matrix was A plus B, right? So we are
Yeah.
allocating the memory in another matrix result, but we are not doing here that thing. We are doing simply in the A itself. I'm adding. So that's all was the difference, and was just returning this pointer. So to the updated this one, and we will store it. So yeah, this is was the main difference. Now, in the value part, nothing was changed. Just instead of the matrix we have to add value to each of the element of the matrix. So we traverse in the matrix 0 to n, I to n, j to n, and then matrix of ij plus equals to n. Okay, fair enough.
Yeah.
So basically, this is how similarly, I think you will be able to implement the minus equal to part also. The minus equal to part is same like what we have done plus equals to here. You just replace this with minus equals to. Just we have to subtract the minus. So I think this was the same part. So this also we have done. This also we have to done. Now let's try to discuss this thing. So multiply equals to. Now again it have two versions. Okay.
Yep.
So multiply equals to. If I just talk about multiply equals to. So basically, again, if we will given a value, integer a or whatever, or we are giving a matrix, or not say exactly matrix, an object only, object b or whatever. Okay, so basically, if we give a means we have to multiply Like same stuff as the plus part, multiply
Yeah.
each element with A. Okay, each element with A with A, and for B, like it's just multiplication of two matrices, multiplication, multiplication, multiplication of two matrices. So basically, what we have done, like suppose we multiply A multiply equals to B. What does it means is like we have to just store A into B. Multiply just the same method what we have multiplied, right? Just we need to call that
Yeah.
and just store in the A itself. That was our another problem. Let me just show you the code. The same stuff, nothing much changed. So yeah, like multiplication, we already know how to multiply two matrices, right? This is very important to try to practice with this multiple times, like how to multiply two matrices. One loop 0 to n, other loop 0 to n, and then the third loop is also 0 to n only because we are taking n cross n matrices only. So yeah, like just the summation of the result of I matrix of ij is equals to, like what we have done here is we have allocated a new matrix, a new result, and then finally, before returning, we are assigning this to our A itself. Like, firstly, what we are doing in result, we are storing the same way we are multiplied the two matrices before, right? Now, what we are
Yeah.
doing before returning, we are storing the result in A, so that our job was done. Like, what does that mean? Like, meaning of this is this only, right? To allocate A into B in A itself. So before returning, we have to do this. So we have done this. Start this, like which is our A only, equals to result, and we have returned our A. So this is how this we have done. So this is before we have to check. Obviously, the argument should be same before multiplying. So assert you can do, throw invalid argument, whatever. This is you can do thing. So yeah, main thing is the see things will be repetitive. You have to learn how to multiply two matrices, that you have to remember basics of operator overloading every time. Okay, how to write the syntax, like write operator and then which operator you want to overload, star equals to, and what was the argument here. So these things, obviously, I'm not able to repeat again and again. If you want, I can repeat it. But yeah, this will be coming again and again. We'll try to focus on this thing. And
Okay.
then this is like, what is the return type? Yeah. So we will be discussing like this. And yeah, like what else left? So this is any doubt till here?
No.
Okay. So what is left? Oh, I guess I think D is done. Let me just check. Yeah, mostly I think this, let's try to, I have created an example as well. So yeah, verify the results also. Let me just show you. So yeah, oh, fuck, it's fine. Yeah, let me just do. So yeah, like we have created all the four functions. So let me just go for desktop. Okay. So basically what we have done is let's try to, let me just try to only. So So yeah, like I have kept the name same only because the previous functions was there only, right? That's why I didn't change the
Yeah.
name, but you should change it like NCC. So yeah, I will share this code as well, so don't worry. And okay, the C matrix pro was our class. Okay, so let's say I define one matrix M1 and we have to give a size also. So let's say 3 only, 3 cross 3 were comfortable. And let's say we are given another matrix pro, and M2, and let's say 3. Okay, so this is
Yeah.
fine. Now let's say try to take the input. So how we are taking the input? sin only. Sin and M1, I guess. Yeah, I think we have overloaded the input part as well, right? Let me just check with the friend function. We have overloaded that part. Where it was like in the previous assignment, it was there like this one, right? Like output stream and input stream. Okay. So just what you need to do, just we have to add in this way, right? Just pass the matrix and yeah. So yeah. So that is in M1. Like sin, I think M1 would be fine only, I guess. Yeah, like we have already, let's try to see is it working. Like we have overloaded the inputs in matrix also. That's why it's showing like this. So yeah, let's try to give an input 1, 2, and 3, 4, 5, and 6, 7, 8, and 9. Yeah, it's working. Okay. So yeah, like this is how we are taking an input. And similarly, let's take the input for B also. And before that, let's try to write a statement to be more clear. Uh,
Yep.
give the input for post matrix. Mhm. And then let's try to write for here for second matrix. Now let's try to check everything. So firstly, let's try to define. See, let's try to define with two different sizes. Then we will assign. So firstly, what we will do? M1 is of 3 cross 3. M2 is of 2 cross 2. What I want to do? M1 equal M2 equals to M1. Okay, so because there are different sizes, so they have all overloaded it. Now we will check is it working or not. So we'll just print M2. Okay, like M2
Mm,
should
okay.
size should be changed and it should copy the elements also, right? So yeah, so M2 is also fine. Okay, let me just do this only. M2 is fine. Now what else? M2 we have printed. Let's try to check this first. Let's is it working or not? Let me just clear this first so it will be clear. Okay, clear. Okay. So yeah, so first matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. Give the second matrix. Let's say 7, 8, 9, 4, 5, 6. Oh, okay, sorry, I forgot. Basically, like it was 2 cross 2 only, right? Oh, sorry.
Yep.
Yeah, so I just gave 3 cross 3 only. Yeah, this is one, 3, 1, 3 cross 3. This one was 1, 2, and then 3 and 4. Yeah, so basically it was
No.
assigned, right? Yeah, this is our output. So our M2 got the correct assignment. So is it working? So yes. Now let's try to give we have checked this so we can like what you can do. Let's change it to 3 only so we can perform our operations. We have checked this thing already. Let's try to check mm, the A plus B wala part. So M1 plus equals to M2 is working or not, and we will print M1 because M1 was changed, right? So
Yep.
let's try to check. We have added the plus equals to matrix and another stage. What we will do? We will add one integer as well. Let's say 8 or not 8, 1 only 5 and count them. Let's try to check it. Hmm. So basically input for first matrix is 1 2 1 1 2 3 4 5 6 7 8 8. Second matrix 2 5 sorry 8. It will become messy. I have to write 9 integers. Like, by mistakenly I just wrote wrong function. Yeah. So basically, yeah, let's try to see. So basically, what he has done, we have added two matrices. Okay, 3, 7, 11. Okay, let me just check. It working? Yeah, like 1 plus 2, 3. 2 plus 5 is 7. 3 plus 8 is 11. 4 plus 3 is 7. So yeah, like we have added two matrices. And in the second part, what was this? Just add one to this. So why it happens here? Because M1 was already updated, right? that's why it added one in that thing. So like it originally it should add here, but we already modified M1, right? So that's why it added one to this matrix. So like 3 to 4, 1, 7 to 8, 11 to 12, 7 to 8. Okay. So
Yeah.
added one to each one, and then we have added two matrices as well. And then similarly, you can check for m1 minus equals to 1, we will originally back to original matrix. Then m1 minus equals to m2, we will reach our original matrix. And then, yeah, like every time we'll just give an handle as well. So basically, to give a nice space. Thing. Hmm. Okay, this is fine. This is fine. Now we have checked m1 and we let's check multiplication as well. So m1 into m2, m1 multiply equals to m2 and sorry multiply equals to m2, right? Yeah, m1 not count should do. Yeah, and now let's try to count m1 and uh, and then last thing just multiply with a random number. So yeah, let's say uh, m1 into 2 only. All multiply will multiply with 1. Okay, so m1 into oh, sorry m1 multiply equals to 2 and count. Okay, let's try to check everything.
Okay.
It works. Okay, let's see. Hmm. Hmm. So basically you got it right how I am giving this like
Yes,
m1
yes,
minus
yes.
1. Oh, so let's try to check. Oh, something happened. M1 does not have a name. Okay, what happens? M1 minus equals to 1. What we have defined? It M1 only, right? Just a second. It's M1. Okay, let me just check. Okay, minus equals to means and a problem. There's no problem. Let me just remove the cons from here, I guess. Let me just check. Yeah, that's fine. So let me just delete it. More clear. Let's try to push it above because many things we have to see. So yeah. So let's try to give the input 3 cross 3 1 2 3 4 5 6 7 8 9. So get like I am giving an identity matrix only so that we were able to see the multiplication also easily. Like it would be same, right? If I multiply something with identity matrix, it would be same.
Yep.
0 1 0 0 0 0 0 and 1. Yeah. So let's try to see everything. Okay. So yeah, this is our addition. So is it giving? I think yes. 2, 2, 3, 4, 6, 6, 7, 8, 10. Okay, this was the addition part. This was what? This was like adding the one to this. We have added one to this. Like each element 1, 3, 3. Okay. Now we have subtracted one from there. Every element 2, 2. Okay, 3 and 6. Yeah, this also works. And what it does is like again we have subtracted from like the sum m2, so we got our original only. What we have done like nothing we have done, like we have added and then reverse that operation, like it was reversal of operation. That's why we got our original matrix. This was original matrix. And then what we have done? Just multiplication. I told you, like if I multiply something with identity matrix, we will get the same matrix. So we got the same matrix. And in the second part, like we have multiply everything with 2. So that's why every element is multiplied by 2. 2, 4, 6, 8, 10, 12, and 14. 16. Fair enough till here?